I think we stopped talking.
Okay, so we talked about classifying polynomials, how to classify it by degree and number of terms yesterday, and then also we talked about negative exponents, how to change something with a negative exponent to a positive. Now we're going to talk about zero exponents, and then you'll have some time to practice this. So, in general, when 0 is an exponent, the answer is almost always 1. So I'm going to show you some examples when this is not the case. Is that yours?
Yes.
Okay. Alright, so if we had some base with some exponent, and I put in different numbers, we know that anything to the first power is itself. 2 squared is 4, 2 to the third, we did 2 to the negative, or negative 2 to the third power yesterday and got negative 8, so this would be the positive version of that. And really in each of these I'm dividing by 2, so if I divide by 2 again, this 2 to the 0 should give me 1. That kind of tracks in all of these different numbers. If I start dividing by whatever the base is, I get 1 at the end. As long as I have parentheses with the negatives, that would also work. However, with this one, with 0, we know 0 to any power is 0. So then by default, this should be 0. We'll test that theory in a second. But also, if everything should be 1, and this should also be 1, it can't be both, put 0 to the 0 power in your calculator. 0 to the 0 power.
Is it 14?
There's an error.
Yes.
Yeah.
Basically, it's undefined because it wants it to be 1 and 0 at the same time, and it can't, so it's undefined. So that one's a special case. 0 to the 0 power will be undefined, not 1. And also, if we had a negative base and we didn't use parentheses, it would be negative 1. So like here, if I had just negative 3 to the 0 power instead of the parentheses, this would give me negative 1. So write this down. Negative bases raised to the 0 power if parentheses aren't used equal negative 1.
Let's write them.
Yes. So those are your two special cases. If you have a negative base and you don't have parentheses, it's going to equal negative 1. If you have 0 as the base, it's going to be undefined. But other than that, it should be 1. So if I say, what is 100 to the 0 power?
No, wait.
1. If I said 1,000,000 to the 0 power, it should be
1.
1. If I said negative 1,000,000 in parentheses to the 0 power,
1.
I use parentheses, so 1. So always 1.
Right.
Always 1. But if I did say negative 10 to the 0 power without parentheses, then it would be negative 1. Okay. So go on to the next page. So then 1.02 to the 0 power is 1. Negative 2 to the 0 power,
1.
also 1. If I didn't have parentheses, okay, great. So if you want to rewrite the rule from the previous page, anything to the 0 power is 1. You could put asterisk, see previous page for the negative basis, or 0 power.
Thank you.
You don't have to write exactly what I wrote. I was just saying what I said, writing what I said out loud. Alright, now let's do some examples with the negative exponents. So before, last class we were doing some with just one variable, one number. Now these have mixtures. So let's start at number 1. First, you have to think about each of these are multiplying separately. Negative 3 doesn't go to everything because it's not in parentheses. So this is the same thing as saying 4 times y times x to the negative 3. 3 different things, just smushed together. The 4 and the y would not change because it doesn't have a negative exponent or a 0 exponent, but the x to the negative 3 can. Using our notes from yesterday, how could we rewrite this?
Over 1 over x. 3.
1 over x to the third power. Is that what you're going to say?
Yeah.
And then we want to write our final answer as a condensed fraction. So you could just combine them all back, or if you want to actually see it, where would each piece go, you could make these fractions, put 1 underneath, multiply across in your numerator, multiply across in your denominator, so you have 4y over x to the third. And that would be your simplified answer. Once you get the hang of this, you don't even have to separate all of this. You can jump right into this. But we'll do a couple separating and then a couple not. Questions so far? Let's do number 3. So in number 3, we have a negative exponent. It's in the denominator already. Right now, the base is 1 over w. If I were to take that and flip it, this would become w to the 4th over 1, or just w to the 4th. So really, when you have a negative exponent, if it's in the numerator, or it seems like it's in the numerator, it's going to go down. It's going to move to the denominator. If it's already in the denominator, it's going to move up. So instead of doing this, you could jump right to this. Know that it's just going to flip. What other ones on this page do we want to see? Do go over, have questions?
Number 6.
Okay. 5. Okay. Let's do those. So now I'm going to start to separate things a little less. So here we have 2 to the 5th and c. The c is not going to change, but we can figure out what 2 to the 5th is. A to the 3rd, negative 3rd is going to change, and b is not going to change. So first, let's figure out what 2 to the 5th is. It's not.
Sorry, yeah.
It's 2 times 2 times 2 times 2 times 2. 32. So I'm not separating these, but there is an invisible multiplication sign in between it. I'm going to leave this as this for now. Because I have a to the negative 3 in the denominator, it's going to get moved to the numerator. B is going to stay in the denominator because it doesn't have a negative exponent to be changed. So I'm going to put this in ABC order and move it to the top and make the exponent positive. So I didn't separate it like we were just doing, but you could. You could do 2 to the 5th times c all over a to the negative 3rd times b, and then change everything that needs to be changed and then move it. Questions on that one? Okay, let's do that with 6. So things that can be changed, we have 4 to the 3rd. We have 3 negative exponents, so all of the negative exponents are going to swap places. And we can figure out what 4 to the 3rd is. So 64, I'm going to rewrite it as is first. You don't have to do each step. Once you get the hang of this, you could start switching immediately. You could simplify immediately. It's really up to you. And then I'm going to switch y down here, 3 to the negative 2 up, and z to the negative z up. So I just swap all the negatives.
So everything that has like the number above it, you like swap it?
A negative exponent. So the -2, the -6, the -2.
Oh.
Then figure out what 3 squared is. And then we have to multiply those two. So 64 times 9.
Okay.
576, x to the third, z to the 6, all over y, I put 6. But that was supposed to be 2.
Oh.
Questions on that? I'm going to give you guys until about 8 to do as many of these problems as you can. Try to get to at least 15. If you can do more, that's great. In the next 10 minutes, I'll give you that time. I'll be walking around. You can ask for help, work together. And then at 8, I'm going to give you the next set of notes, and we're going to start it very briefly. And then stop. Alright, before we talk about the notes I just gave you, Kareem, seat. Do we have any we want to go over, see, had questions about? Number 15. 15.
Who said it?
Did you have one?
No.
Okay, which one? 6. Okay, we'll do 6 and 15. So with this, because it's a negative, it's going to come up, and we're multiplying. And then you could put that all in your calculator. You could do 4 to the third, and then multiply it by 4.
Okay.
Whatever that is. 256 would be that answer. For 15, 32 is going to get moved to the denominator. 8 is going to get moved to the numerator. So basically these are going to switch. You can put the 1, you don't need the 1, and then you can divide or simplify. If you had put either of these into the calculator, it would have also given you the right answer. Now all of these won't do that, but some of them will.
Are we gonna have to show our work, like, when we're doing the presentation?
So right now, no. When it gets a little bit more,
Complex.
right? Other questions there? Look at the notes I just gave you. I just want to see if you guys can figure out the rule. If you already know it, don't say it. No, we're going to do it. Okay, so for number 1, if I had x squared times x to the 4th, and I expanded that, x squared would be x times x, times x to the 4th would be x times x times x times x. What would that be total?
That would be X.
Oh, okay.
I know.
We'll do one more, and then if you think you know the rule, you can say it. For number 2, if I were to separate and expand all of this, I have 4 times a times 4 times a times a times a. And then I'm going to rearrange it, put the 4's together. And I can see I have 2 4's. And how many a's? 4. So then if I simplify this even more, 4 squared is 16.
16.
It's okay. So that is a common mistake that I see often here, that we multiply the numbers instead of multiplying itself. So make sure you are multiplying itself. Do we think we know the rule yet?
You just put it together. be together. Like
You kind of simplify.
like a sandwich.
You
You
get it?
Not quite.
Like, I understand, but
It's very yeah, like you condense it.
My bad.
that's what I said. What she said. You're like,
You're
You are, in a
condensing.
way, yes.
yeah, but like you're like making it from a two
How am I gonna
number
ever use this, like-
equation to just one. I don't know.
We're simplifying somehow, yes. So we'll do number 3 and let's see if you guys can figure out the rule. So there's a specific rule when it comes to multiplying exponents or multiplying terms together. So if I were to do this one, I have n times 4 times n times n times n times 7 times n. I'm gonna move the 4 and the 7 out front, but they're not the same, so I can't like make an exponent with them. I'm just gonna multiply those. And how many n's?
6.
So then if I simplify this further, we have 28.
Okay, yeah, come on.
Anyone notice what's happening with the exponents on all the same bases?
Right there. Not there.
If I were to solve this without expanding it, how could I figure out this is 6? Are they
Oh,
multiplying?
2 times 3. So you can multiply.
Remember that this is an exponent of 1, though.
Oh.
And would that also work here?
I don't think so.
No, because this has an exponent of 1.
Oh,
We didn't multiply those to get 4.
You add.
Oh.
So if I add the exponents of like bases,
Oh,
you get whatever it is. So that is the rule.
I know.
That was obvious.
I thought like it was like more confusing.
So when multiplying like bases,
I say putting them together is like another one for addition.
not necessarily. When multiplying like bases, you add the exponents. Are there any others on that page we want to see you go over?
Going once. Going twice. Going 3 times. Sold to nobody.
Make sure you have this rule written down. We are not going to do the next page until tomorrow, but hold on to these. If you have any questions on any of this so far or anything we've already talked about, make sure you come see me after school today. Reminder, you have 2 Delta Maths that are due on Friday. One is classifying polynomials. The second one, you won't be able to do until we completed this packet of notes. But you can definitely try or start it. The first part will be the negative exponents. Some of it may be what we just did, but more will be later.